In this video, we will go over the two most popular shooting mechanic in FPS, namely the projectile method and the Hitscan method. Since the Hitscan is the most popular one by a wide margin and is utilized in pretty much all of the FPS games like in Call of Duty, Valorant, Counter-Strike, etc., we will go ahead and implement this one as the part of our tutorial. In Hitscan, unlike the projectile method, wherein you actually shoot a bullet out of your gun, you instead shoot a raycast. This raycast is a straight line of definite length and returns the result of the first object it has collided with, be it a wall or an enemy. If it is the latter, you register as shooting the enemy, and not if it is the former. Cool, let us now implement this. Here is a basic boilerplate project that we will be using. Nothing much, just a moving head with a shoot animation and an area 3D whose collision layer is set to our enemy one. You can get this boilerplate project as a downloadable in the description box below, or if you're interested in creating all of this for yourself, check out the previous part of this tutorial series. Back on the topic, here is our pistol scene. We will now make our hit zone. You can think of this as the range of our gun. That is, the enemy should be inside this area when we are shooting our gun for it to be registered by our bullet. There is one more reason why we are doing this, but we will get there when we start writing our code. So, in summary, we have a area 3D as a hit zone or a hit box with enemy as its collision mass. In the code part, we just have an input trigger that runs our shoot animation once we press our mouse button. Inside it, we will call a check and shoot function. This function will check for the first enemy that is within our range and if possible, then shoot it. First, we will have to get the list of all the enemies within our range. For this, we can use the get overlapping areas function of our hit zone. This is a built-in function provided by the area 3D class and returns a list or array of all the areas that is within our hit zone, that is our area 3D. So how shooting works in an hit scan mechanism is that if multiple enemies are within your range, you will only shoot the nearest one. So for this, we will have to sort our enemy array in ascending order based on the distance it is from you. For this, we will use our custom sort function. This is a built-in function provided to us by Godot that allows us to sort our array using the custom comparator that we will provide to it in the form of a lambda function. In this comparator, we will compare two values of our array A and B and will return true if enemy A is closer to us than enemy B, and if it is true, then our A will be placed before B in our array and the opposite if it is false. We will now iterate through all the enemies of our array until we reach the first enemy that can be hit by our raycast. For our raycast, we will use this snippet of the code, which is being provided to us straight from the Godot's documentation. Let's go over each of the lines one by one before we integrate this with our code base. First, we get the current state. You can think of it as a snapshot of our current 3D world, wherein we can run complex physics operations. That is our raycast queries. Next are the starting and ending points of our raycast. We will change them anyway, so I will not go into details of what these current expressions do, as they are not relevant to the code. Next, we run our ray query between the starting and the ending positions, and then finally return this query's result. This is the reference to the first object that has collided with our ray between the starting and the ending point. Now, since our ending point will be our enemy's position, we will have it be the argument to our function call and mark the starting point of our ray to be our global position. We will then call this query for each of our loop's iteration, and if our query's resultant collider body is the same as our enemy, we will mark it as shooting our enemy and not if otherwise. And since we have already shot the nearest enemy, we don't need to further run this for loop, so we can just break out of it. If we do not do so, we will instead hit multiple enemies along our path. Now the only thing left to do here is to signal our enemy that some damage has been dealt to it, which I will explain in the next part of this tutorial series, where we design our enemy and our enemy AI. But if you already have your game's enemy all designed up, you can just call your damage signal here. And yeah, that is pretty much it for today's part. Hope you guys liked it, and if you did, press the like button and subscribe. See you next week.